I wasn't even supposed to be there that day. My uncle had taken me on one of his field trips. Not the kind where you get on a bus with a packed lunch and visit a museum. No, this was a real field trip. The kind where you wear
It
muddy
really is
boots
quite
and carry
amazing.
tools that look like they belong in a toolbox, not
I
a
believe we
science
have
lab.
something truly special here.
My uncle is a
Ouranopithecus.
paleoanthropologist, basically a fossil detective who tries to figure out how humans came to be. That summer, he was digging in northern Greece. And that day, we found something that would change how I saw the world forever. It all started with a sound. A scraping sound, soft but sharp, like a spoon against rough stone. My uncle was kneeling by the edge of a shallow trench, gently brushing away some dust. He paused and squinted. I leaned closer. That's when I saw it, something sticking out of the dirt. Not a rock. Not a stick. Something different. He called it a mandible. That's the fancy word for a lower jaw. It looked ancient, thick, curved, with huge molars. I remember him whispering under his breath, could it be Ouranopithecus? At the time, I had no idea what that meant. Ourano what? I asked. Ouranopithecus, he said, his voice serious now. It means ape from the heavens. Sounded like something out of a space movie, but what he meant was even cooler. Ouranopithecus wasn't just any ancient ape. It was one of the earliest known apes that might be linked to the story of us humans. And this one might have lived before the African ancestors most people talk about in textbooks. That moment, it was like touching a time machine. That dusty jawbone had waited in the earth for over 9 million years. Here's the thing, when most people think about where humans come from, they think about Africa. Fossils like Australopithecus, Homo habilis, and Lucy, they're all found in East Africa. And yeah, that's a huge part of the story. But what if the roots go even deeper? What if they go back to a time when apes roamed not just Africa, but Europe too? That's where Ouranopithecus comes in. He or she lived around 9.6 to 8.7 million years ago, during the late Miocene epoch. At that time, the world looked totally different. Picture this: lush forests, warm grasslands, and scattered lakes covered parts of what is now northern Greece and southern Europe. It wasn't exactly paradise, but it was teeming with life. Giant elephants called dinothers, saber-toothed cats, three-toed horses, and, these mysterious, powerful apes. Ouranopithecus was big. Some researchers believe males could weigh up to 70 kilograms, as much as a grown man. That's way bigger than modern chimps. Their jaws were massive, with thick molars, adapted for chewing tough, fibrous plants, maybe nuts, hard fruits, or roots. But what makes Ouranopithecus really special isn't just the size or diet. It's the face. See, when scientists look at fossils, they don't just want to know how big the creature was. They look at clues about posture, movement, brain size, and even social behavior. The skulls of Ouranopithecus show a flatter face than a chimp's, with forward-facing eyes and strong cheekbones. That might not sound like much, but it's important. Those features look just a little more human. Some experts even think that Ouranopithecus might have walked upright, maybe not like we do, but in a way that shows it was heading in that direction. So why don't we hear more about it? Well, here's where the mystery gets juicy. Most scientists have believed for years that our direct ancestors came from Africa. That's been the dominant theory because of all the fossils found there. But Greece? Europe? That complicates things. The fossils of Ouranopithecus were first found in the 1970s near a village called Ravin de la Pluie in northern Greece. Since then, more have turned up near Chalkidiki and Thessaloniki, not in giant skeletons like in museums, but in pieces, teeth, jaws, skull fragments. It's like trying to put together a 10,000-piece puzzle when you only have 15 pieces. But each of those pieces tells a story. One of the most famous fossils is known as Ouranopithecus macedonensis. That's the one most scientists talk about. It's not just an ape, it's an ape that lived in the same time frame when humans and apes were thought to split from a common ancestor. In other words, this could be the missing chapter. Back at the dig site, I sat on the dirt and looked at that jawbone like it was a treasure from another world. My uncle was already taking measurements, snapping photos, and logging the coordinates. You know, he said, every fossil changes the story. Just a little. I asked him if Ouranopithecus was really one of our ancestors. He didn't answer right away. Instead, he looked out over the dry hills and said, maybe. Maybe not. But if it's not the ancestor, it's at least a cousin. A very, very old cousin. The thing about science is, it's always evolving. New discoveries don't erase the old ones, they just fill in the blanks. Like adding a new paragraph in a book we've been reading for centuries. Some scientists still argue about Ouranopithecus. Was it a dead-end species that disappeared? Or was it part of the branch that led to us? Did early hominins, creatures more human than ape, first appear in Europe, then migrate to Africa? Or did Ouranopithecus just look similar to our ancestors, without actually being one? Nobody agrees yet. But here's what everyone can agree on: Ouranopithecus walked the earth during a turning point in evolutionary history. Whether he was a great uncle or just a distant cousin, he was part of the big, tangled family tree that eventually led to me, and to you. That night, I lay in my sleeping bag under the stars, wide awake. I kept thinking about that jawbone. About the way the earth had kept it hidden for millions of years, like a secret. And how it took a gust of wind, a bit of brushing, and someone curious enough to look twice to bring it back to light. I realized something: maybe the dawn of humanity didn't begin with fire or tools or cave paintings. Maybe it began way before all that, with creatures like Ouranopithecus, roaming forests that no longer exist, leaving behind clues in stone and bone. Not just fossils. There's something wild about standing where an ancient ape once stood, something that gives you chills, even when the sun is burning down on your neck. A few days after we found that jawbone in northern Greece, my uncle took me deeper into the region near Thessaloniki, to another fossil site. He said it was one of the oldest dig locations where Ouranopithecus remains had been discovered. The place didn't look like much, just some rocky hills and thorny bushes, with little paths worn into the soil from years of research teams coming and going. But to my uncle, it was sacred ground. This, he said, pointing to a layer of exposed earth halfway up a slope, is where the story deepens. By now, I had learned a lot more about Ouranopithecus. Not just from my uncle's excited rambling, but from watching the way the dig team worked. They treated every scrap of fossil, every shard of bone, like it was made of gold. And in a way, it was. It held answers. But here's the twist. Ouranopithecus didn't live alone. He wasn't some lone evolutionary hero marching toward humankind. No, he lived in a world full of other animals, some of them towering and terrifying. And understanding them helps us understand him. Let's rewind the clock to about 9 million years ago. Europe wasn't Europe the way we know it. There weren't cities or highways or airports. There were warm, humid forests stretching across parts of what we now call Greece, Turkey, and the Balkans. Rivers flowed through valleys. Herds of strange animals grazed in meadows, and predators lurked in the undergrowth. It was a land ruled by giants. I'm not just talking about dinosaurs, they were long gone. I mean massive mammals like Deinotherium, a distant relative of modern elephants but way bigger, with downward curving tusks that looked like giant hooks. Imagine standing next to one of those. Then there were the amphicyonids, sometimes called bear dogs, which were exactly as scary as they sound. They had the body size of grizzly bears but the jaw structure of massive hunting dogs. No thank you. These creatures weren't just scenery, they were players in Ouranopithecus's world. They shaped how he lived, where he went, and even how he might have evolved. So, how did Ouranopithecus survive in a place like that? From what paleontologists can tell, he was a terrestrial ape, meaning he spent a lot of time on the ground, not just swinging in trees like modern chimps or orangutans. His massive jaws and teeth suggest a diet of hard, fibrous foods that he probably found by foraging on the forest floor. Maybe he dug up roots. Maybe he cracked open nuts with those heavy-duty molars. And maybe, just maybe, he walked upright. Not like a human taking a stroll in the park, but upright enough to free his hands occasionally, to carry food or defend himself. Some scientists have debated this for years, and there's no solid proof yet. But certain features in the bones, like the shape of the face and the positioning of the spine, hint at something different from the tree-swinging apes we know today. If that's true, then Ouranopithecus might have been testing out a brand new way of moving through the world. A way that would one day become our way. Now here's something that surprised me. Ouranopithecus wasn't the only primate around at the time. There were others. Earlier in the Miocene, Europe had been home to apes like Dryopithecus, which lived in trees and had a body more like a modern gibbon. Then there was Grycopithecus, another mysterious hominid whose jawbone was found in the Balkans. Some researchers even think Grycopithecus might be an early hominin, which means part of the human family tree. But Ouranopithecus stood out. Bigger. Stronger. More adapted to life on the ground. My uncle called him the survivor. Why? I asked. Because he was the last of his kind, he said. The last of the European great apes before they disappeared. That hit me hard. Imagine being the last of your kind. No cities. No family history. Just trying to survive in a shrinking forest, while the climate changes around you and the world slowly turns against your kind. That's another part of the story: climate change. Around the time Ouranopithecus lived, Europe started getting cooler and drier. Forests turned into open woodlands. Food sources became more seasonal. Some animals adapted. Others migrated. Many went extinct. Apes like Dryopithecus, which depended on trees and soft fruits, couldn't handle it. But Ouranopithecus? With his tough teeth and flexible habits, he held on longer than most. He was a generalist, not a specialist, and that probably gave him an edge. Still, it wasn't enough. Over time, the great apes of Europe vanished. And so did Ouranopithecus. Or, did he? That's the big debate. Some scientists think that Ouranopithecus, or one of his close relatives, migrated into Africa as the climate changed. The idea is that as Europe became less friendly for apes, some populations moved south, crossing what is now the Mediterranean region when it was possibly more land than sea. There, in the rich forests of East Africa, they may have continued to evolve. And if that's true, if Ouranopithecus made that journey, then he may have helped plant the seed of what would become human evolution in Africa. A bold theory? Definitely. but the jawbones and skulls we've found could be telling us that early hominins didn't start in Africa, they started in Europe. That night, back at camp, I asked my uncle something that had been bugging me. If Ouranopithecus was so close to us, how come nobody talks about him in school? He didn't laugh. He just nodded, like he'd been waiting for me to ask. Because the story keeps changing, he said. And people are slow to change with it. Science is weird that way. It's built on evidence, but it also needs time. Sometimes, even when the bones are screaming out a new chapter, people are still reading the old one. But the more fossils we find, the harder it is to ignore the voices from the past. The story of human origins might be bigger than we thought, stretching beyond Africa, across ancient forests, through lost apes like Ouranopithecus. That's what I learned out there. The truth isn't always where you expect it. Sometimes, it's buried under centuries of assumptions. Sometimes, it's hiding in the dirt, waiting for someone to listen. I remember waking up to the sound of cicadas buzzing and dust blowing into the tent flaps. The heat in Greece during August is no joke, but the strangest thing was after just 2 weeks out here, I didn't mind it anymore. I felt like I had stepped out of my own time and into someone else's world. And in a way, I had. We weren't just digging up fossils. We were digging into stories. Stories about a time when Europe wasn't filled with cafes and scooters and noisy cities, but with dense forests, strange creatures, and apes like Ouranopithecus, who lived in a world we can barely imagine. But I wanted to imagine it. I wanted to know what it looked like. Not just the bones, but the forests. The rivers. The smells. The sounds. So that day, I asked my uncle, what was it really like here, when Ouranopithecus was alive? And that's when he told me about the forgotten forests of Europe. Back around 9.5 million years ago, Europe was in the middle of a huge transformation. The climate had already started cooling. The seas were changing, land bridges formed and disappeared, and lush, tropical forests were slowly giving way to open woodlands and grasslands. But for a while, just long enough, there were still pockets of humid subtropical forest in places like northern Greece and Bulgaria. These forests were rich, diverse, and alive. Imagine towering trees like ancient oaks, magnolias, and conifers stretching toward the sky. Beneath them, thick layers of leaf litter covered the forest floor. Streams and rivers cut through the landscape, attracting animals big and small. This was Ouranopithecus's home. He wasn't climbing rainforest vines or sleeping in high branches. He probably spent most of his time on the ground, moving between patches of forest and more open land, dodging predators and searching for food. His world wasn't quiet, either. Picture the deep rumble of Deinotherium herds passing through the lowlands. The crack of branches as amphicyonid bear dogs prowled nearby. The calls of ancient birds, the buzz of insects, the howl of wind through dense underbrush. It was beautiful but also dangerous. And it was vanishing. One of the most important things my uncle explained to me is that fossils don't just tell you about bones, they tell you about environments. We found pollen grains fossilized in clay, tiny seeds fossilized in sediment layers, and even bits of fossilized wood. Each one of those was a clue to what the ancient forest was like. Scientists call this kind of research paleoecology, reconstructing ancient ecosystems based on fossil evidence. From these clues, we know that Ouranopithecus didn't live in a rainforest, like modern orangutans. He lived in a mixed woodland, with both trees and open areas. That means he had to be flexible, able to adapt to different food sources and environments. That flexibility may have been his superpower. We also found ancient soil layers stained with iron, which shows there were seasonal floods and dry spells. Some parts of the land would have been muddy, others dusty. Plants would bloom in bursts, then vanish for months. Ouranopithecus had to survive not just predators and competition, but a changing climate. He was built for it, at least for a while. I sat on a rock that afternoon, just outside the dig site, and tried to picture the forests the way they once were. I imagined Ouranopithecus moving cautiously through the underbrush, his big eyes scanning the treetops for figs or nuts. Maybe he moved in a group. Maybe he carried an infant clinging to his back. Maybe he climbed trees to sleep or took shelter during storms. And maybe, just maybe, he stood on 2 feet to get a better view of the world around him. That's the part I couldn't stop thinking about. Most modern apes walk on all fours. Chimpanzees and gorillas use their knuckles. Orangutans swing through trees. But Ouranopithecus? There's a theory that he might have started using bipedalism, walking on 2 legs occasionally or even regularly. It's not proven, but some researchers think it makes sense. In a shifting landscape with less forest canopy, standing upright to move between trees or to carry food could have been a useful trick. And if Ouranopithecus was experimenting with upright walking, even a little bit, that puts him one step closer to us. We don't know for sure, though. The problem is we haven't found his pelvis or leg bones. Those would be the parts that tell us if he walked upright like a human or still moved more like a gorilla. But the face, the skull fragments and jaws, those tell us he was different. One fossil in particular stuck with me. It was a partial skull discovered at the Zyrokouri site in Greece. The brow ridges were heavy, and the face was broad and flat, way flatter than a chimpanzee's. The teeth were massive, worn down like he had been chewing hard foods for years. But the thing that got me was the eye sockets. They faced forward. That sounds normal, right? But for a primate, forward-facing eyes mean depth perception, good vision, good focus. These are the kinds of traits that help you move through complicated environments and maybe even understand social behavior. That skull had once held a brain. Not a big one like ours, but a smart one. Smart enough to survive, to adapt, to raise offspring. Maybe even to form relationships, like alliances, friendships, or rivalries. We'll never know what Ouranopithecus thought or felt, but his bones suggest he was aware, alert, and navigating a complex world. Just like us. But here's the sad part. As the forests shrank and the seasons became harsher, the world Ouranopithecus depended on began to crumble. Fewer trees meant less fruit. Longer dry spells meant less water. Competition with other animals grew fiercer. And slowly, the European apes disappeared. Dryopithecus vanished. Grycopithecus left only a few mysterious bones. And Ouranopithecus? Well, he held on longer than most. His powerful jaws and adaptable habits kept him going through the worst of it. But even he couldn't outlast the environmental collapse. By about 8.7 million years ago, his kind had vanished from Europe. But that doesn't mean the story ended. Some scientists believe that before Europe's forests vanished completely, a small population of apes, possibly Ouranopithecus or his relatives, migrated south. They might have crossed land bridges into Africa, chasing food, water, or safety. If that's true, then the forests of ancient Greece may have given birth to the very first hominins, our distant ancestors who would one day stand fully upright, make tools, and tell stories around fires. That night, I sat under the stars again, but this time I wasn't thinking about just Ouranopithecus. I was thinking about the forest itself. The roots that once cracked the soil. The leaves that once fed creatures now long gone. The rivers that once shaped the land. And how it's all gone. But not forgotten. Because those forests, even if they've disappeared, left behind their story. In bones. In pollen. In rocks. And in apes like Ouranopithecus who, even after 9 million years, is still whispering from the dirt. One afternoon, I was helping clean a set of fossilized teeth my uncle's team had just pulled from a site near Chalkidiki. They were dark brown, smooth, and worn down like tiny mountain ranges. The grooves were so deep you could have hidden grains of rice inside them. These are the teeth of a survivor, my uncle said. Maybe the last of his kind. I glanced up. Last. He nodded slowly, then reached into his bag and pulled out a folder stuffed with papers. Diagrams, maps, and photos spilled out across the field table. He tapped one of them. It showed a timeline like a ladder climbing through millions of years of primate evolution. And right there, between the 10 million and 8 million year marks, was the name, Ouranopithecus. Then I saw it. A fork in the line. A split. On one side, Europe. On the other, Africa. And that was the big question. Did we, the human species, start our story in Africa, as everyone's always said? Or is it possible just maybe that it started in Europe, in these forgotten forests where Ouranopithecus once walked? The idea that humans came from Africa is the most widely accepted theory in science. It's called the Out of Africa model, and for good reason. We've found hundreds of early human fossils there from Australopithecus afarensis, you've probably heard of Lucy, to Homo habilis, Homo erectus, and beyond. Most of these fossils date from about 4 million to 2 million years ago. They were clearly early humans, or hominins, meaning they were more human than ape upright walkers, tool users, with expanding brains. But Ouranopithecus? He lived around 9 million years ago. Way earlier. So if he's even remotely connected to us, the story might be older and more complicated than the textbooks say. Let's break it down. Ouranopithecus was discovered in Greece and neighboring regions like Macedonia and Bulgaria. Fossils have shown up in at least 3 different locations, including Zyrikkuri and Ravindalapalli. What's fascinating is that these fossils are not isolated, they belong to both males and females, which suggests we're not just talking about a random visitor or a dead-end species. Some scientists think these European apes could be stem hominins, the earliest forms of primates that eventually gave rise to our human ancestors. One of the most important things they look at is teeth. Yeah, teeth. Turns out, teeth are a huge deal in paleoanthropology. They're tough, they fossilize well, and they hold clues about diet, age, and even genetics. Ouranopithecus had thick enamel, similar to modern humans and unlike most modern apes. That might mean he ate harder, more abrasive foods, maybe nuts, seeds, or fibrous plants. That thick enamel is a human-like trait. Then there's the jaw and face structure. Ouranopithecus had a relatively flat face, not as protruding as chimpanzees. His cheekbones were broad. The distance between the nose and the mouth, called the subnasal area, was short. Again, more human-like than ape-like. All of this has made scientists wonder, was Ouranopithecus part of the line that led to humans? Or just a close cousin? Here's where it gets even more interesting and controversial. In 2017, researchers published a study about another fossil, Grycopithecus freybergi, found in Bulgaria and Greece. This fossil included a partial lower jaw and a tooth root, dated to around 7.2 million years ago, which is older than some early African hominins. The researchers argued that Ouranopithecus might actually be the earliest known hominin, even older than Sahelanthropus jotensis, found in Chad, Africa, which was long believed to be the first. If that's true, then the very first hominins, the first branch of the family tree that led to humans, might have appeared in Europe, not Africa. And guess who would have come before Ouranopithecus? Ouranopithecus. Of course, not everyone agrees. Many scientists pushed back hard against the Europe origin theory. They said that the fossils weren't complete enough. That one tooth doesn't make a species. That migration could have happened the other way, from Africa into Europe. After all, the continents weren't completely cut off back then. The Mediterranean was shallower in places. Climate and tectonic shifts created land bridges. Apes could have moved back and forth more than once. So who's right? We don't know yet. But here's what we do know: Ouranopithecus is a major piece of the puzzle. And until we find more fossils, especially leg bones or a full skull, we won't be able to say for sure where he belongs. Still, that doesn't make the story any less exciting. In fact, it makes it more human. Because that's what humans do: we ask questions, we argue, we dig for answers. Sometimes literally. Back at the campsite, I was lying under the stars, staring at a sky Ouranopithecus would have known. No buildings, no airplanes, just open space and silence. Why does it matter? I asked my uncle. Does it really change anything if humans came from Europe or Africa? He thought for a moment. Then he said, it changes how we see ourselves. It changes the story we tell. And he was right. Because the story of human origins isn't just a timeline in a textbook. It's our story. A story about survival, migration, climate, and adaptation. It's about beings that learn to cope, to walk, to eat new foods, to raise children, to communicate. And every fossil, every Ouranopithecus, every tooth, every cracked skull is a sentence in that story. Maybe even a chapter. I imagined Ouranopithecus again, strong, broad-faced, chewing through a tough seed pod, squinting into the sun. Maybe he had no idea what the future held. Maybe he didn't need to. But we do. Because by studying him, we learn not just about where we came from, but why we are the way we are. Why our teeth are shaped like this. Why we walk on 2 feet. Why we adapted when others didn't. Maybe Ouranopithecus was one of the early steps across a dry savanna, through the shrinking forests of Greece, towards something new. And if that step began here in Europe, then maybe the dawn of humanity wasn't tied to a single continent after all. Maybe it was global. Maybe it started in more than one place, at the same time. And maybe, just maybe, the answers we're looking for are still waiting, buried in dirt, worn by time, whispering through the rocks beneath our feet.